All right, welcome back to 7.8. This is a remake of 7.8 because there were some statics in the previous video. So here we go. Anyways, we will review 7.7 first. We were solving log equations, and here are two questions for you to review. Okay, so here we go. So what we can do is we can apply the rules of logs, which means here we have two logs subtracting each other. Therefore, we can actually divide them. We can be careful though, not dividing the two logs together, but the 7x minus 1 over x. Okay, you can divide them, and this will be log base 5 of 4. Now, because since both sides are log base 5, so then you can simply say that, okay, well then we have 7x minus 1 over x equals to 4. Okay, from here you can multiply both sides by x. You should get 7x minus 1 equals 4x. Moving the 7x to the left or to the right, then you get 4x minus 7x, which is negative 3x. And then you can divide both sides by negative 3. You should get x equals to 1 over 3. Okay, and now from here, you should check by plugging 1 over 3 into x and see if that gives you any negative values, because remember, we cannot log negative numbers. And 7 times 1/3 should be 2 1/3, minus 1 is still 1 more than 0, so that's fine. So if you plug in here, this is positive. Plug in here, that's positive. That means we're going to be okay. Okay, so that's part A. Part B is slightly trickier. What we need to do is, again, apply the rule. Here we can we can move this exponent of 2 to the front. So we end up with 2 times log base 4 of x. On this side, be careful. On the right, you cannot bring the 2 to the front because this square is for the entire thing. It's for the entire log, not for the x. So there's actually nothing we can do about this. Okay, so we're just going to copy this down. Now what I'm going to do though is I do see that this and that, they are like terms. Okay, so what I'm going to do is I'm going to move this, the one on the left, to the right. So we end up with log base 4x squared minus 2 log base 4x, and this should equal to 0. And like I said, we have common factor here because both terms contain log base 4x. If you factor this out, you should end up with log base 4x times log base 4x minus 2. Oops. Square bracket equal to 0. Which means you either have log base 4x equal to 0 or log base 4x minus 2 equal to 0. Right? So in this case, well, x would simply be 4 to the power of 0, which is 1. In this case, you get log base 4x equals to 2. Therefore, x equals to 4 squared, and that is 16. Okay, so then again, we can plug these two values back into your original equation. And yeah, plug in 1 into x and x there. There's nothing wrong. We can evaluate log of 1. That's not a problem. It's just not negatives nor 0, right? We can plug in 16 into x and x here, and again, that's fine. So we would have our solutions here, x equals to 1 and x equals to 16. Okay, so that's the review from previous section. And we're going to go back a little bit further. We're going to look at this compound interest question because this has something to do with what we're going to be doing later on today. Okay, so he says a principal of $5,000 is invested at 3% annual interest, compounded monthly. How long will it take to the nearest year for the investment to double? So recall, the formula that we learned was A equals to A0, A naught plus 1 over, times 1 plus I over n to the power of nt. nt. So if we want to double, that means we will end up with $10,000. We start with 5,000. 1 plus the interest rate, which is 3%, so 0.03, divided by n. This is compounded monthly, so divided by 12. 12 times t. Okay, so now you can see we can divide both sides by 5,000 first, so you should end up with 2 equals, and I'm going to put this into calculator, 0.03 divided by 12 plus 1, so this is going to be 1.0025 to the power of 12t. Okay, now from here you can log both sides. You should get log 2 equals to log of 1.0025 to the power of 12t. Now we can bring 12t to the front. You should have 12t times log 1.0025. So to solve for t, you simply take log 2 and divide it by 12 and log of 1.0025. Put this into calculator. Let's see what we get here. We have log 2 divided by bracket 12 log 1.0025. Okay, so you should get about 23 years. Okay, to the nearest year, yeah, 23 years. Okay. Well, the answer is 203.13, and again, obviously, it's going to take more than 23 years. But for the purpose, again, I'm not worried too much about the actual, amount of time, how many months. That's okay. We're just reviewing, right? Using this formula, we get 23 years. Okay, so how is this related to what we're going to be doing today? So when you invest money, there are usually two different ways, right? I mean, there's two different ways. Okay, one is like what we're doing here. You put money in, you leave it there, and then you let it grow, and you don't touch it at all for 3 years, 2 years, whatever, right? GIC, something like that. That's when you put in money, or savings account. You put it in, you just leave it there, and hopefully 3 years later, it becomes well, it will be more because it gives you annual interest. So hopefully it gets to however much you want. So that's the first way. Okay, you put it in, don't touch it, leave it for 3 years or whatnot, and you get your final amount at the end. Or more popular option is this one here. It says when a series of equal investment is made at an equal time intervals. So for example, you could invest every month, every week, every 2 weeks, and so on. And the compounding period for the interest is equal to the time interval for the investment. The amount of dollar, this is what we call the future value, of these investments can be determined using this formula. Okay, so again, the biggest difference here is for future value, you set aside money each month or each week, every 2 weeks, and so on. So you invest $100 into your account every 2 weeks, instead of putting aside $1,000 and put it into the account for a year, okay, and you don't touch it. So instead of a lump sum, you put it into a smaller amount, but you do it regularly. Okay, so every 2 weeks, every month, and so on. Okay, that's what we call the future value. Okay, so a little bit different. This again is a more popular option. People usually put in, $100 every month to save, and then let it grow. Okay, that's one way to invest your money, is by what do they call it? Shoot, I forgot what they called. Every bank has its own name. PPP, I think it's called pre-authorized payment, something like that. Okay, PEAP, whatever, something like that. You can figure out when you are ready to invest. Okay, but that's one way of doing it. Okay, so it says here's the first example. It says determine how many monthly investment of $100 would have to be made into a savings account that pays 4% annual interest compound monthly for the future value to be $100,000. Okay, so again, this means we are investing $100 every month, and we want to see how long it's going to take to get to $100,000 with 4% annual interest rate compounded monthly. Okay, so here's the formula. Future value is going to be $100,000 because that's what we want in the future. R stands for the regular payment. Oh, actually, I probably should read this first. R is the regular investment. I is the interest rate per compounding period. So this I is a little bit different than I that we used to use. Okay, it's actually interest rate per compounding period, not just the interest rate. And N is the number of investment. And so here we go. So R is $100 in this case. 1 plus I, which is going to be 0.04 divided by 12. To the power of n, that's what we're solving for, minus 1, divided by I, again that's 0.04 over 12. Okay, so we're solving for n. So first step is I need to multiply both sides by 0.04 over 12, 0.04 over 12, so they cancel out. Okay, so I'm going to put this into calculator. 0.04 divided by 12. You should get 333.3 repeating equals to 100. Whoa. 100 times 1 plus, what is this? This is 0.003 repeating, I want to say. I think that's right. To the power of n minus 1 divided by 100 on both sides, right? Divided by 100, so that goes out. Divided by 100, you should end up with 3.3 repeating equals to 1 plus 0.003 repeating to the power of n minus 1. Okay. Now to solve for n, I need to move this 1, so plus 1 on both sides. You end up with 4.3 repeating equals to 1.003 repeating to the power of n. We can solve for n by taking the log on both sides. So log 4.3 repeating is equal to n log 1.003 repeating. Okay, so to solve for n, that's going to be log 4.3 repeating divided by log 1.003 repeating. Okay, so on the calculator, I think we can get to this 4.3, not a problem. So I'm going to divide by 100 on my calculator and then plus 1. Okay, so I can take log of that, not a problem. Log answer. But because your calculator can only remember one answer, so you can't really type in 1.003 repeating on the calculator. So what you do then is you type in log 1.00 and then just press a lot of 3's, okay, many times. Okay, then this will give you 440.6. So I would say 441 months. Okay, so it takes 441 months if you invest $100 each month at a 4% annual interest rate compounded monthly to get to $100,000. Okay, so on the side note, I want you to figure out how much money did you actually put in, okay, like money from your pocket. Okay, so if you invest for 441 months times $100 every time, you actually put in $44,100, and this actually grows to $100,000. So you actually pay less than the desirable amount at the end, and and you still get your $100,000, even though you actually pay less than half. So this is the power of exponential growth. Okay, so it's actually quite incredible. Okay, it does take some time, right? 441 months. How many years is this? Divided by 12. 441 divided by 12. This is 36 years and 9 months. So it does take time, right? But think about this: if you start at years, at the age of 22, 22 plus 36, that's 58, right? That's still a good amount of money to have before you retire. And I'm sure you can probably, well, I don't know. It depends on everybody's situation. You probably could invest more than $100 a month. However, though, 4% is not. It's difficult to get 4% guaranteed interest rate. So, anyways, you can figure this out when you again are ready to invest. Okay, so here's the second example or practice question. I'm gonna let you try it, and I'll show the answer in a bit. Okay, good luck. All right, so hopefully this is what you got. Okay, so basically what happened here is it's basically the same question, but you see, I just changed the annual interest rate to 6%. So the power of 2%. Okay, it's just a little different, right? Not much. From 4% to 6%. It actually makes a huge difference. It takes 441 months if it's at 4%, but if it's at 6%, it actually only takes 360 months, which is 80 months less, which is almost 7 years. Okay, only difference of 2%. It makes a 7 years difference. Notice though, when you solve it here, it's actually 359.2, but you might argue, then why didn't we round it down to 359? Why should we round up to 360? Because, well, at 356 months, it's not quite enough to be 100,000, right? You need to have that 0.2 of a month, which makes it 360 months. Okay, that's why I round up instead of round down. Okay, So it does make a huge difference, even if it's just 2%. 6% is what you can expect if you invest smart. Okay, if you do it right, 6% is something that you could expect. Obviously, sometimes bad things happen. Last year, right, COVID-19, or actually this year, this March, this February, oh, the market drops a lot. Okay, that was not an easy month to endure for a lot of people. Okay, health-wise, money-wise, yeah, that was difficult. Okay, so that's future value is investing, and of course we cannot just talk about making money, because sometimes, I mean, investing means I'm making money for the future, right? But a lot of times I need to buy things like right now. I need to buy a house. I need money. I can't wait 36 years, right, to get money to buy a house, because then house is going to be more expensive later on, right? So I need to buy a car right now, right? So I need money. So what we do then is we borrow money from the bank, and this is what we call present value. Okay, present value means I need money now, so I need the money in this present, at this present, right? So it's present value. So this is the loan. Okay, so we are borrowing money. All right, so here, basically, if you look at the equations, okay, the formula is actually very similar. Okay, R still stands for regular payment. So in this time, though, in this case, you are paying it back, right? You're not investing, you're returning money. I, same thing, it's the compound interest rate per compounding, sorry, it's the interest rate per compounding period, and N is the number of payments. Okay, so here's the example here. A person wants to borrow $100,000 as a mortgage to buy a house. Probably this person doesn't live in Metro Vancouver. $100,000 as a mortgage. Well, you could still buy something, I guess. Not much though. Okay, the person can afford to pay $1,000 a month. The mortgage will be repaid with equal monthly payments at 2% in annual interest rate. This is actually quite relevant right now. It is around 2% right now. Compounded monthly. How many monthly payments will the person make? Okay, so same thing. Okay, we want to borrow $100,000. This is the money that I want right now, that I need right now. This is going to equal to I afford to pay $1,000 back each month. And let me look at the formula because I don't remember it. 1 minus 1 plus the interest rate of 2%, compounding monthly to the power of negative n, divided by I, which is 0.02 over 12. Okay, so same thing, multiply both sides by 0.02 over 12. That will cancel those two terms out. So let's see, 0.02 divided by 12. Okay, I'm going to write this side first. So this is going to be 1 plus 0.02 over 12 is going to be 1.0016 repeating to the power of negative n. Okay, and I'll take this times $100,000. Okay, so you get 166.6 repeating, divided by 1,000 on both sides. And divided by 1,000, so they will cancel out. Divided by 1,000, 0.16 repeating is equal to 1 minus 1.0016 repeating to the power of negative n. Minus 1, minus 1. This will give us negative 0.83 repeating, I think. Minus 1, yes, equals negative of 1.0016 repeating to the power of negative n. Divide both sides by negative 1. So the negative sign cancels. You get 0.83 repeating is equal to 1.0016 repeating to the power of negative n. Okay, now we can again log both sides. You'll get log 0.83 repeating is equal to negative n times log of 1.0016 repeating. Therefore, n is going to equal to log 0.83 divided by negative log 1.0016 repeating. Okay, so I'm gonna put this into calculator. So log the answer divided by bracket negative of log 1.0016. Again, a lot of 6's because it's repeating. Okay. And then the calculator tells me that this equals 109.5. So if I pay $1,000 each month, it will take me 109.5 payments, which means I need to make 110 payments. Obviously, the last payment is not going to be full $1,000, okay? So you'll pay the full you'll pay the full $1,000 109 times. For the last payment, you'll pay whatever that's left. So it's not going to be, well, so approximately to borrow $100,000, and given the situation, the total that you actually need to pay, well, I don't know why I put it into calculator. I don't need it. This is actually the amount of money that you paid to repay your $100,000 at this moment, right? So for the entire duration, 110 payments, you pay around $110,000 for the $100,000 that you borrowed, right? So you paid basically $10,000 would be your interest, right? That's how much money you pay extra on top of your mortgage. Okay? Hopefully that makes sense to you, right? Because you borrow $100,000, so you can use that, but you just need to pay $10,000 more as the interest. Okay. All right. So that might be still ways away for you to think about buying a house. Buying a car might be more relevant to you. So I'm going to ask you to try this one and see what you get. Okay. Good luck. All right, so here is the answer. Again, just plug in the values and solve for n. You should get around 56. So it would take you 56 monthly payments. So that's roughly 5 years. And if you multiply that by your monthly payment of $300, that is again roughly $16,800, which means you actually paid $1,800 as the interest to borrow $15,000. Okay, to buy your car. All right, so that's the first two examples are about money. Obviously, life is more than just about money, so we're gonna move on to a different example. And log is used in different areas, right? We know I don't know if you know. If you take chemistry, you'll know that pH is about log. Okay, because it's base 10. Okay, it's tenfold. Richter scale. So the earthquake, the magnitude of the earthquake is also base 10. So this has something to do with log as well. Intensity of sound is also base 10. So there are some different examples in life that it's actually base 10. And pH you can learn on in chemistry. It actually works similarly. Okay, so but I'll show you Richter scale. Okay, so in October 2020, Alaska experienced an earthquake with magnitude of 7.6. 4 days later, Fiji experienced an earthquake with magnitude of 6.1. The question is, how many times as intense as the Fiji earthquake was the Alaska earthquake? So I think we can tell that Alaska earthquake is more intense, is stronger because the magnitude is bigger. But we want to know how many times bigger. Okay, so it's if you you might think it's okay. Well, then 7.6 divided by 6.1, right? Like that. Unfortunately, it's not like that. Okay, because again, these Richter scales really is about base 10. So the intensity of the Alaska for Alaska earthquake is actually 10 to the power of 7.6. Okay, and the intensity for the Fiji earthquake is actually going to be 10 to the power of 6.1. So if you want to figure out how many times it's intense, it's going to be 10 to the power of 7.6 divided by 10 to the power of 6.1. So dividing is right, except that you are actually dividing with 10 to the power of the magnitude. Okay, so this actually tells you the intensity. It's not just 7.6, it's 10 to the power of 7.6. Again, remember, earthquake is about base 10. Now this we can reduce to be 10 to the power of 1.5. And now we put this into calculator, 10 to the power of 1.5. It is actually 31.6 times bigger, or as intense. Okay, so the earthquake in Alaska was actually 31.6 times as intense as the one in Fiji. Okay, so not just 7.6 divided by 6.1, but 10 to the power of 7.6 divided by 10 to the power of 6.1. Okay, so it's base 10. That's why you got to do it that way. Okay. So here are 2 questions for you to try, and I'll show you the answer in a bit. Okay. Good luck. Okay, I'll show you part B. I will do part B together, actually. Okay, so part A, how many times is intense? So you can see the magnitude in Chile was 9.5, but the one in Alaska was 7.6. So the difference in magnitude is only 1.9, but it's actually 79 times as intense. Okay, so it's actually quite a bit stronger. Okay, even though the magnitude only shows 1.9 difference. Okay. Okay, part B. It says if there was an earthquake that is 21 times as intense as Alaska, what would the magnitude be? Well, we know this means then 10 to the power of this magnitude divided by 10 to the power of the magnitude in Alaska, which was 7.6. This should equal to 21. Okay, so this is what we're solving for. Okay, again, 10 to the magnitude of this particular earthquake divided by 10 to the power of 7.6, which is the magnitude of the Alaska earthquake, should equal to 21 because it says it's 21 times as intense. So to solve this, you can do it a couple different ways. You can multiply both sides by 10 to the power of 7.6, or we can use the exponent law, which means because we're dividing with the same power, with the same base, we can subtract the exponent. So 10 to the power of x minus 7.6 should equal to 21. From here, then you can turn this into log form, or just simply log both sides. You should get x minus 7.6 times log 10 is equal to log 21. Okay, and hopefully by now you know that log 10 is simply just 1 because it's base 10. So we have x minus 7.6 is equal to log 21. Therefore, to solve for x, we take log 21 and then add to 7.6, which we can put into calculator. Log 21 is 1.3, so plus 7.6 is going to give us 8.9. Okay, so 21 times as intense means the difference in the magnitude would be 1.3. Okay, so that is it for this lesson. Log exponential functions, they are actually quite useful in life. So, different kind of OR problems we can use, right, that we have. Okay, so there are questions for you to try, and let me know if you need help. Otherwise, good luck. See ya.